Today is Wednesday, November 4th, and today we'll be going over lesson number 16. And our specific lesson today is about solving situations. Our learning target today, I will accurately solve two-step problem situations involving mixed operations. So, two-step problem situations, that means you got to do more than one thing to actually solve it, okay? Involving mixed operations. And our essential questions are remaining the same for the entire unit. We're just continuing to build upon them. How do we make sense of larger numbers? And how does understanding the value of digits help answer real life math problems? And on this page, we're going to do some work on a Jamboard in just a few minutes. But it's the same as page number 181 in your math binder. So I'm going to click here just to go in and go to our Jamboard, and it brings up a problem, and I'll go ahead and read it. Marcia had 20 stamps. Her sister had twice as many stamps than Marcia, but then her sister used 3 of her own stamps to mail letters. How many steps does Marcia's sister have left? So for this problem, I've gone ahead and done my maps on it. I've circled the key numbers. Marcia had 20 stamps. Then her sister used 3, so 20, and then 3 of her own stamps. And there's some key words in here. So her sister had twice as many. So her sister had twice as many stamps as Marcia did. So remember, you're going back to most multiplicative comparisons. We think about twice as many. That means she had 2 times as much. Okay. And our key question here is, how many stamps does Marcia have left? Marcia's sister have left. So how many stamps does Marcia's sister have left? So you should be going through and rereading this problem. So I want you to go through and reread it on your own. So you'll notice that this is actually a 2-step word problem. This is a 2-step word problem. That means we're going to have to do take not just 1 step to solve it. We're going to have to take 2 steps to actually find our answer. And one of the strategies that you should be using is basically try to visualize or to retell the actual problem. Okay, that means you go back and repeat it as many times as you need to. Usually for me it will be 2 or 3 times to really read it and understand what is it actually asking you. So I want you to go ahead and use whatever strategies that you already know, that we've already learned about, and go on and try to solve this right here. You can solve it right here on any of the blank space that we have. So you've had an opportunity to go through and try to solve it. I'm going to actually go back to our slides really quickly here. And our next slide actually is telling us to delete the Earth stamp to reveal the answer to the problem that we just worked on. So I'm going to go here and I'm going to delete it. And this is what we have. Let's go on and take a look. All right. So Marcia had 20 stamps. So the first part up here is indicating Marcia. Marcia had 20 stamps. So let's just say that this little part represents 20, okay, for Marcia. And then her sister, and the S stands for the sister. The sister had twice as many as Marcia. So you're going to have not just 1, but 2 times this amount. And 2 times 1 is 2. So she's got 2 different ones, okay? So if one of these represents 20, then this one represents 20, and this side represents 20, and 20 plus 20 is 40. So her sister had 40 stamps. Okay. So the question is, her sister used 3 of her own stamps to mail letters. So her sister used 3 of her own stamps to mail letters. So her sister started out with 40, and you have to subtract. So if you use up your stamps, that means that you no longer have them. So you have to subtract them. 40 minus 3 is 37. So 40 minus 3 is 37 stamps. So how many stamps does Marcia's sister have left? She's got 37 stamps left. Okay? And our equation would be 40 minus 3 equals 37. So on our next slide, these are some questions that I want you to consider. These are some questions I want you to consider, and write your answers for these just inside of your notebooks. Write your answers inside your notebooks, and we'll just take a look at one or two of them. So how do we know these problems involve more than one step? So how do we know that these problems involve more than one step? And I'll go back up to our Jamboard. So Marsha had 20 stamps. Her sister had twice as many stamps than Marsha. But then her sister used 3 of her own stamps to mail letter. How many stamps does Marsha's sister have left? Okay, how do we know? Now let's take a look at, it gives us, what's the known? The known is that Marsha has 20 stamps. Okay, so that's the known. And her sister had twice as many. So it's giving us a clue right here for twice as many. That's a multiplicative comparison. So we have to figure out this clue. And then her sister also used 3 of her own stamps. So then we have to figure out, well, how many does she have after she used 3 of her own? And then we can get our answer. So there are several steps here that it's really giving us clues to, and that's how we know that we've got to figure out more than one thing. And we'll just go over and look at one more here together. Does this problem involve multiplicative comparison language or additive comparison language? So we're going to go back to that particular problem. And you remember that's one of the ones we already indicated here, twice as many. So just thinking back on some of our earlier lessons in the first quarter, twice as many is representative of multiplicative comparisons. Okay, multiplicative comparisons. So moving on to our next slide, it is introducing us to page 183, 184 in your book. So 183, 184 in your binder. These are the problems that you're going to be working on, and they are 2-step situations. Now on the next slide, I've got some tools that you can use to kind of help you solve those problems as you work them in your book. Okay, so these are some tools that can help you. We've got the base 10 blocks that can help you, and we've got a number line that you can use. We've already practiced with both of these, and we'll take a look at the first one here on that page 183. Okay, so this is the first problem on page number 183. This is number 1. Rick keeps his Pokemon cards in a box. Rick's uncle gave him 6 packs of 8 trading cards to add to his box. Rick found that 29 of the trading cards from his uncle were different than any of the Pokemon cards he already had in his box. How many of the trading cards from his uncle were the same as those that Rick already had in his box? Okay, and let's take a look at this one. This is a multi-step problem. And I've already gone and done the cubes on this one, guys. I've circled the key numbers. 6 packs given to Rick by his uncle of 8 trading cards. Okay, so 29 were different than the ones he already had. Now underline the question, how many of the trading cards from his uncle were the same as those that Rick already had in his box? So I've boxed in a key word right here, the same. So the question is, how many were the same as what he already had in his box? All right, so one of our first steps is try to determine the first part right here at the top, and that's going to be how many did his uncle give him? So how many cards did Rick's uncle give him? He gave him 6 packs of 8 trading cards. So there's a few different ways you could do that. So you can have 6 groups of 8. You can have 6 groups of 8 and add them all up. 1, 2, 3, 4, 5, 6. So this is actually repeated addition. So you got 8 trading cards, but there are 6 packs of them. So there's 6 groups of 8. 1, 2, 3, 4, 5, 6 groups. So when you add them all up, you're going to get 8 plus 8 is 16, plus another 8 is 24, plus another 8 is 32, plus another 8 is 40, plus another 8, 48. Okay? So we got 48 cards that were, we'll say, added to him. That were added. It was given to him by his uncle. Another way that you could solve that 6 packs of 8 is simply by multiplying them. 6 times 8, 48 added. Okay, same answer. All right, so we can't stop right there. This is how many were added, were given to him from his uncle. Okay, he found that 29 of these that he got from his uncle were different than any of the cards he already had. So 29 were different. Okay, and once we figure out the difference between what was added, the 48, and those 29 were different, that's going to give us the remainder are going to be the ones that were the same. So our next step is to subtract those 29, and those 29 were different. So I'm just going to say different right here. So when we subtract, and this is going to take some ungrouping, 8 minus 9 you can't do because the bottom number is bigger than the top. So I'm going to change my color. Remember, you go here and you ungroup that 4 in the tens place. Now you have 3. You add the 1 to that 18, and you have 9. And then 3 minus 2 is 1. So that we're 19, and that represents the same. So 19 were the same. Okay? And so 19 were the same. We know that. So now we actually have our answer. We have our answer up here, but it wants the equation. So we're going to say 48 minus 29 equals 19 were the same. So we'll leave that like that, okay? All right, so that's problem number 1 on page 183. So we did several different steps on here. So this is also on page 183. This is also on page 183. And this is number 2. Rick's uncle also gave him a book to hold Pokemon cards. To fill one page of the book completely, 10 trading cards must be placed on the page. Rick will place the 61 trading cards he already had and the 29 new trading cards in the book. What is the total number of pages Rick will fill completely in the book? So I'm going to just reread that one. Rick's uncle also gave him a book to hold Pokemon cards. To fill one page of the book completely, 10 trading cards must be placed on one page. So on one page, there has to be 10 on there to fill it. Rick will place the 61 trading cards he already had and the 29 new trading cards in the book. What is the total number of pages? Total number of pages Rick will fill completely in the book. Okay. So here we've got he has 61 trading cards that he already had and 29 new ones. So let's figure out the total number of cards that he now have. Okay, how many do we have right now? So you've got the 61 plus the 29 cards, and that gives us, and we've got to regroup here, 1 and 9 is 10. So I'm going to bring that 1 over to the tens place, and now I have 1 plus 6 is 7 plus 2 is 9. So 90 cards total. Okay, so now we figured out how many cards he have. All right, and we also know that he needs to put 10 per page, 10 on each page, okay? So how many total pages will he need? So you know you've got 90 cards, but you can only get 10 on each page, and you want to fill every page up. So how do you figure out how many pages that you need here. Okay, so you can say, you can use it as a division problem. Okay, you can say 90 divided by our 10 equals what number? All right. Now, because of the inverse operations, we can also find our answer by doing this. 10 times what number equals 90? So 10 times what number equals 90? And because of how we can use our zeros, we know that what number times 1 equals 9 is 9. And then if you added when you multiply 10 times 9, you add the 0, that makes it 90. So 10 times 9 equals 90. So our answer here is actually 9. So the total number of pages that he's going to need to fill his book is 9 pages. And we're just going to take our equation, and we can use the one we got right here for that, okay? So 10 times 9 equals 90, and our answer are 9 pages. And I'm going to label that 9 pages right here, okay? Okay, so we're going to go to number 3. Problem number 3 is on page 184. So page 184, I'll write that here. Problem 3 is on page 184. And here we have a teacher has a total of 2 pencils and 6 markers in her desk. The teacher needs a total of 50 pencils. Each package of pencils has 6 pencils. How many packages of pencils are needed for the teacher to have a total of 50 pencils in all? So I'm just going to reread that so I can get a better understanding. And you should get in the practice of rereading the problems also. A teacher has a total of 2 pencils and 6 markers in her desk. The teacher needs a total of 50 pencils. Each package of pencils has 6 pencils. How many packages of pencils are needed for the teacher to have a total of 50 pencils in all? So I've already done my cubes on here. So I've circled the key numbers, 2 pencils, 6 markers, 50 pencils, 6 pencils, 50 pencils in all. And I've also kind of boxed in some keywords here. So it says how many packages of pencils are needed. It doesn't say markers, it says pencils. How many packages of pencils are needed for the teacher to have a total of 50 pencils in all? And I also boxed in all. So for the teacher to have a total of 50 pencils in all, what is it going to take? Okay, so here she needs 50 pencils, and she already has 2 pencils. Okay, so she already has 2 pencils, but she needs 50. So it needs a 50 total. So how many more does she need? That's the first thing we need to figure out. So how many more does she need? And in order to do that, we need to subtract. Okay, so the 50 represents the pencils needed. So that represents the pencils needed, and the 2 represents 2 pencils already that she has. Okay, so we subtract that, and remember here we have to do some ungrouping because you cannot say 0 minus 2. So we go over here and we ungroup that 5 to 4, and then we come up with the 1. So that leaves us with 8. So 48 pencils are needed. Okay, so right now we know that there are 48 pencils needed. So each package, and she still needs, she needed 50 total, and we just figured out, okay, since she's already got 2, she only needs 48. Only needs 48 more. And now we need to determine about the packages. Well, how many packages of pencils are going to be needed? All right, so each package contains 6 pencils. So there are 6 pencils in each package. All right, and she needs 48. So there's a couple different ways you could do this. We could simply say 48, and it could be a division problem, divided by 6 equals, I'll separate that, equals, and this would give me the total number of packs of pencils. Okay, so because of the inverse operations, we could change this around. We can say 6 times what number equals 48. So knowing your math facts, you know that 6 times 8 equals 48. So that would be 8 packs are needed. 8 packs are needed. Okay, and we're gonna take this one and we can move it up here to there. Okay, so 8 packs are needed because of a couple of different operations that we had to do. Okay, so now we're on number 4, and this is also still page 184. Page 184 in your math binder. The teacher now has 6 markers in her desk and 48 pencils. So she has 6 markers in her desk and 48 pencils. She will buy 9 packs of markers. Each package has 4 markers. How many more pencils does the teacher have than markers? So how many more pencils does the teacher have than markers? I've gone ahead and done my cubes on it. So I circle my key numbers, 6 markers that she has in her desk right now, 48 pencils that the teacher has in the desk right now. She's going to buy 9 packs of markers, and each package has 4 markers. So how many more pencils does the teacher have than markers? All right, so we already know how many pencils she has. She has 48 pencils, but we don't know how many markers because she started out with 6 in the desk, but she's buying more markers. So we need to determine how many total markers she has first. And we're going to say for the packs of markers, we need to figure out how many is she going to buy. And let's see, how many is she going to buy? So 9 packs of markers, there are 4 in each. So one operation that you can use is multiplication. 9 times 4 is 36. That's going to be 36 markers. Okay, or you could do a repeated addition. So 9 packs of markers. Each package has 4. Okay, so each package has 4, so you can do 4 groups of 9. 9 plus 9 plus 9 plus 9. Okay, when you add those up, 9 plus 9 is 18. You add another 9, that's 27, and another 9, that's 36. Okay, so you get the same answer. All right, so now we know how many markers are going to be bought. Okay, so that 36 markers bought, and she already has 6 in her desk, right? She already has 6. So let's add those up. So the 36 that she bought, we're going to add the 6 that she already has. So 6 for this, we got the regroup here. So 6 plus 6 is 12. We bring that 1 into the tens column. So 1 plus 3 is 4. So 42, the total number of markers. So 42 is the total number of markers that she has. Now, does that answer our question yet? It says, how many more pencils does the teacher have than markers? Okay, so there's one other operation, one other step we got to do. So we already know that she had more pencils, which is 48. So now we need to find the difference between the 48 and the 42. So we're going to say the 48 right here, and I'm going to come back up here and erase this part. So 48 that we have up here, and we need to find the difference. So that means you have to subtract 48 minus the 42 that we have down here. And that's going to give us the difference. 6 markers is the difference. Okay? 6 markers is the difference. So we've got the 36 plus the 6 equals 42. And then we said 48 minus 42 equals 6. 6 more pencils. And that's our answer. Okay, so on our next slide, this is for your independent work. So you're going to turn to page 185 in your math binder. That says 3, 2, 1, ready, set, reflect, and rate. So on page 185, you want to complete it and then take a picture of your work, and I want you to insert it right here on this particular slide. Okay, so our last slide, so a reminder, completing page 185 in your binder, take a picture of it and insert it into the previous slide. Your second task is to complete the Khan Academy assigned lessons that you have.